A very good morning to everyone. This is Dhanlakshmi, Assistant Professor from Department of Computer Science and Engineering, Kognada College of Engineering and Technology. I'm handling of Digital Logic and Computer Organization. Now we are going to discuss about the Unit 3 of Computer Fundamentals. First of all, in the first topic, we have going to see the fundamental units of digital computer, that is a von Neumann architecture. The computer architecture is nothing but it's a blueprint of how the computer components work internally. So there are various experts are designing or giving various architecture, but the foundation as well as the most important one type of architecture is the von Neumann architecture. Now we are going to discuss about the von Neumann architecture. Before that, we have to know about the different types of computers we are available now. The first one is the fixed program computers, that is it's a very specific, the function is very specific, we can't able to change or we can't able to reprogram it in some other ways. For example, calculators. In calculator we can go fix the program or cannot be reprogrammable as our needs. But in the second one is the stored program computers. The stored program computer is nothing but our desktops and laptops or standalone computers. In this type of computers, we can able to change the software and we can reprogram the software as per our needs. And why we are going to discuss about the von Neumann architecture is it is one of the popularized stored program computers, as well as the computer is flexible, and we can the flexible in terms of we can able to reprogram the software as per as our needs. And the most one important one is the design is basically made for to store both the data as well as the instruction in the simplified memory. Based on this type of architecture, we can simplifying the hardware design as well as for general purpose computing. So this is what the architecture of von Neumann. The first thing is the memory, and the second thing is the processor and input output device. Now we can see how the von Neumann architecture functions. First of all, the user can give the input through the input devices. After that, the operating system will allocate the memory as well as the processor for processing the operations. First, the input will be fetched into the memory, and the memory is allocating for the particular process. After that, it will compile, and if anything for a basic operation like arithmetic or logical operations, it will enter into the arithmetic and logical unit. Here is the accumulator is there. The accumulator is nothing but a register. It can store the intermediate results of the operations. And the second one is the control unit. In the control unit, it is basically used for switching off the control signals for the entire process. So here, what is the main memory? For each and every operation to be executed, it should be fetched into the main memory. This is a thumb rule for the execution of the operation. The main memory is made up of a large number of registers, flip-flops or counters or anything else. Here we can able to store the data as well as the instruction in the main memory itself. It is used for storaging as well as the retrieval of the information. So control unit, as I said earlier, it is mainly used for controlling the entire process by switching over the control signals from among the components of the computer. It directs the flow of the data between the CPU and some other components internally in the processing unit. So arithmetic and logical unit, we can able to perform various arithmetic operation as well as the logical operations as well as the decision making process also. Input, through the input devices, the user can give the input to the system for processing the operation. The output is another type of devices. The user can able to see the output of the process. So processor is nothing but we can able to say is the brain of the computer or the central component. It is the main thing to direct all the processes of beginning from the access of the input from the user, processing and the switching of the control signals and produce the output. The entire process will be performed based on the processor commands. So accumulator It is a one type of register that stores the intermediate or results of arithmetic as well as the logical operations. So memory. So memory, for each and every operation we have to store the input as well as the output in the memory. So in the terms of memory, the operating system will involve a crucial role for allocation of the memory as well as the assigning of the address for the data where it's stored as well as the instructions. So control, it will manages the flow of data between the memory and the CPU. So as we said earlier, it is a core processing unit, CPU, and the program counters as well as the instruction registers are available there. In case of program counter, it keeps the tracks of the address of the next execution to be executed. It will maintains the address of the next instruction to be executed in the CPU. So instruction register as well as it holds the current instruction which is to be executed currently. Ma'am, there is a two other registers just specifically designed for the memory unit: memory address register as well as the memory data register. Memory address register is nothing but it stores the address of the memory location of the instruction that is being accessed. And memory data registers, it temporarily holds the data it is just being transferred to and from the memory. Why we are using the memory register for specifically means to increase the processing speed as well as the fetching of the instruction without any delay. So control unit, it coordinates the activities of the CPU as well as the managing the data flow among the components as well as between memory and CPU. And the general purpose register, of course, it is mainly used for temporary storage of data during the processing. So bus, how the data will be communicated among the components, different components of the CPU is done through the bus. So it's nothing but a communication channel or communication system that transfers data, addresses as well as instruction for processing the data and control signals between the CPU, memory as well as the IO devices. In von Neumann architecture, a single bus is shared for both the data and the instruction, which create a bottleneck also. This is known as the von Neumann architecture bottleneck. So IO interface. The interface is nothing but as a it is a connection device which connects the CPU and memory to the input-output devices. So the next topic is the operands and the operation of the computer hardware instruction. So operands and operation, which is nothing but the operands is a data which is going to process through the particular operation which is specified in computer instructions. So now we are going to enter into the operation in a computer instruction. What is the meaning of the computer instruction means, which is nothing but a binary code. In the computer system, each and everything should be maintained in terms of the zeros and one, which is nothing but your binary code. In that specification only, the operation code is designed. It can be characterized into the specific group of instruction of each and every instruction can be characterized into operation code as well as the address. Operation code is nothing but opcode, which specifies the instruction which is going to perform on the operand. Basically it is a binary code, that's why you are specifying each and every operation in terms of the binary code. And address, the address determines the registers where the data is stored and how when the data will be retrieved and how the output of the particular operation is stored and it is visible to the user. So here the operands are different elements of the computer instruction on that the particular operation will have to be performed on or operated on. So it consists of 12 bits of memory that are required to define the address of the memory. It includes only 4096 words. The 15th bit instruction of the instruction determines the addressing mode, whether it is a direct addressing mode or indirect addressing mode. In case of direct addressing mode, the addressing mode flag will be set to 0, or otherwise it should be set to 1. And the instruction format includes 12-bit addressing mode, 1 bit for addressing 12-bit address, 1 bit of addressing mode, and 3 bits of opcodes. So this is what the basic structure for the instruction format, or the how of the instruction is stored in the main memory. So for the 0 to 11, it specifies the addresses. It includes 4096 words and is the opcode. The opcode is nothing but the operation that the user wants to perform on a specific operand. It should be registered in the it should be shown in the shown or specified in 3 bits, as well as the addressing bit. The addressing flag of the addressing bit is specified here is 1. So it means we have to use for the indirect addressing mode. So now we are going to see about the addressing mode. The addressing mode is nothing but it defines the address of the memory locations. So the method in which the target address or effective address is recognized within the instruction. So here the direct addressing mode as well as the indirect addressing mode. In direct addressing mode, we can able to store the address of the specified operand directly. But in case of indirect addressing mode, it facilitates the pointer of the address of the operand. It represents the address of the operand in terms of the pointer. So this is what the indirect addressing mode. And the effective address. The effective address is nothing but is a target address for the branch type instruction, or the address that can be used directly to create a for operand for the computation process without creating any new changes in that. So opcode, it is a collection of bits that represents the basic operations. This is just basically a binary code that represents the specific operation that have to be performed by the user. There should be either addition or subtraction, multiplication, complement, or shift. It specifies for both arithmetic as well as the logical operations. The minimum bit accessible to the opcode should be n for 2n operations. The operations of this opcode will be stored in a register or accumulator for the intermediate results. From based on the intermediate results, we can able to perform the final operation. So the next one is address. It specifies the specific location of the operand as well as the operation. Based on the instruction, the operand will be performed certain operation. There is another possibility included the address. Address of the operand, this is nothing but your indirect address. So this is what the diagram for how the direct and indirect operands works. In case of direct address, the first bit for the addressing mode will be set to 0, and in case of in this example, in the address 300, we can able to go through the control signal will switch over to the address 300. Here the direct operand is there. The system will perform the operation directly based on the operand. In case of indirect addressing mode, the addressing mode will be set to 1, and here the address will be set to 200. The control signal directly flow to the address of 200. In there is another address that is a pointer of the operand. This we can able to say is a pointer. It holds the address of the operand. The one address holds the address another address of the operand, which is termed as the indirect addressing. And the control signals will flow to the 1000 address 1200. Here they are having the operand. The operation will be performed based on the operand. So the next one is the instruction set architecture. The instruction set architecture describes the basic operation. It defines a basic operation based on certain instructions. How the computer works based on the instruction set. It is the implementation specific. It can able to say describes the implementation specific details of the computer. It only concerned with the set or a collection of basic operations. So there are 3 different types of instruction. Here the every instruction will be processed in MIPS, that is millions of instructions per second. So there are three different types of instructions we are going to perform: arithmetic and logical instruction, data transfer instruction, branch and jump instruction. Arithmetic and logical instructions, based on this types of instruction we can able to perform arithmetic and logical operations. The data transfer, as we know, everything, as I said earlier, it is a transfer of instruction from the memory to the processor as well as the CPU, and vice versa is also possible. Branch and jump instructions, it is responsible for breaking the sequential flow of instruction. For it, it is happens when the page hit or stall occurs on the process, the control signals will directly switch over to the particular locations to fetch the data for the execution, for the further execution of the process, and it is necessary for the implementation of functional as well as the conditional statements. This is the architecture for the enter communication. So we have the arithmetic and logic unit here, and memory address register and memory data register, everything will be connected to the internal bus. So this is the IR and a program counter. Here the address of the next instruction to be fetched here, and the IR holds the current instruction to be executed. These two registers are maintained to increase our processing speed, and without any stall the process could be executed. Thank you.